Good evening, everyone. My name is Sam Nasser, and this is the Azure Cleveland User Group. A little bit about the group. We meet every second Wednesday. The meetings are free of charge and open to the public, and we cover a variety of topics related to Azure, both infrastructure as a service, platform as a service, and software as a service. You can find meeting information posted on meetup.com at the link listed below, and you can also find past meeting information as well if you're interested in finding resource links pertaining to certain meetings. You can find it all on the Meetup site. Some general information, please keep in mind participation is encouraged. The only stupid question is the one not being asked, so feel free to jump in with any questions or comments. However, when not speaking, kindly ask you to mute your mics to avoid any background noise. And we like to keep it casual but organized in the sense that we want to allow for any questions or comments at any point in time, but at the same time, allow enough time for our speaker to go through the slides and the demos. And lastly, the presentation is being recorded and will be posted on YouTube with the link provided later during the presentation. And as far as the presentation for tonight, we have Donovan Brown presenting on Demystifying Helm. Donovan is the partner program manager in the Azure CTO Incubations team, where basically he focuses on forward-looking development and innovation to help facilitate development of newer projects and ideas. He previously worked as a process consultant and a certified Scrum Master, and he helped global companies develop solutions using agile practices. Overall, he's an avid programmer where he likes to integrate programming and software into his own hobbies, and I would love to hear more about that, especially since you're a car buff.
Yeah.
But without further ado, let me turn it over to Donovan.
Perfect. So you should be looking at a Twitter homepage.
Yep.
Yep, and that's pretty much the About Me slide. You said get through the slides. I don't have any slides. I just say, hey, look, you want to know how about me? Like, this is the best way to figure out about me. I tweet a lot about technology, obviously. That's my passion. Every once in a while, you'll see some project cars on my Twitter account and some of my fun hobbies as well. I'm a professional air hockey player, and I used to stream events right out of my house and wrote software that would allow you to use an Xbox controller to actually score the event while it's in live. It was awesome. That was a lot of fun. I ran a online motorsports registration site for 20 years. I just sunsetted it at the beginning of 2021, so I could just focus full bore on Microsoft. But that's another example of me taking software and bringing it into my hobby of racing cars, bringing software, bringing it into my hobby of playing air hockey. I'm also an avid 3D printer, and I actually printed parts for my race car. So I printed like the door handles and other gadgets and stuff I need in the car. I just print them myself, which is awesome, especially when the car is so old that you can't buy those parts anymore. I can just go find one in a junkyard, model it, and then print as many of them as I need, which is a lot of fun as well. So big car guy if you're into cars, BMWs specifically. But what I'm here to talk to you about today is a project called Helm. As Sam said, I work on a team that's an incubations team. Most of the stuff that we do is cloud native. And when you're talking about the cloud and you're thinking about microservices, you're probably going to start working with Kubernetes. And once you start working with Kubernetes, you're going to become really familiar with this thing called kubectl, which is where you type all these commands so that you can add objects to your Kubernetes cluster, remove them from your cluster. It's a pain in the butt, and it's a lot of typing. And if you make a mistake, you're frantically trying to undo all that stuff that you did. And Helm actually makes that a lot easier. The first time I heard about Helm, though, I didn't get it. It said it's the package manager for Kubernetes. I'm like, I don't need a package manager. I don't need another NPM equivalent for Kubernetes. What I need to do is deploy my own apps. I have tens of hundreds of these stupid YAML files that I need to apply all at once or remove all at once. And a package manager is not what I needed. So I said, Helm's not for me. And I tried to figure out ways to writing PowerShell script or Bash scripts that did all the kubectl commands for me. And then my friend said, no, like that's actually what you need. Like, you just got to go learn it. So I went and I downloaded a couple Helm charts. And if you've ever seen a Helm chart, and we'll look at a few of them today, they're quite intimidating, especially when you download one from the internet that has all these ingress controllers and deployments and services and everything. You're like, man, this is like a lot of stuff. And they're scary looking when you first see them. I was able to cobble one together and get it to work, but I could not tell you how it worked. And if you changed any character in there, chances were it was going to break and I wasn't going to be able to get it to work again. So I got it to work, but I didn't understand it. Months go by, I don't need Helm. All of a sudden I need Helm again, and I have to learn it all over again because I didn't really learn it the first time. I just got it to work. I got so frustrated when I joined this team because now all of a sudden I'm using Helm a lot and I'm still not quite getting it. That one day I said, that's it. I'm going to learn this thing. I'm not going to just use it and get it to work. I'm going to understand why Helm does what it does. I'm going to start from an empty folder, and that's what we're going to do today together, is we're going to start from an empty folder, and we're going to go file by file, character by character, till we all are like, yep, I understand what Helm does and why it's valuable, and then we move on forward on this journey together. But this is what we're going to be talking about. The way that we're going to be talking about that is through another product that I'm a huge fan of, right? So this is called Code Spaces. And GitHub Code Spaces is the ability to have an environment spun up in just seconds that has everything that you need already configured. So when I do a Helm demo, I have to have a Kubernetes cluster. I have to have kubectl installed. I have to have Helm installed. And I don't want to have to prepare that environment every single time I'm asked to give this talk. So what I did instead is I created a code space that has kubectl installed, Helm installed, PowerShells installed, Kubernetes clusters installed, everything's ready to go. And I say, hey, I need this environment, and then I'm ready to rock and roll and do my demo for whatever conference I'm doing it for. You can get huge ones, like you can get up to like 32 cores in there, 64 gigs of RAM. So these are much more powerful than the laptop that you might be using to connect to it, where you're actually able to use all that power as you're doing your development, which is awesome. And I've actually started doing a lot of work on Web3, and I've been using code spaces to build amazing environments for developing in Web3 as well, which maybe in the future I'll come back and talk to you about. But again, this is what we're going to be using, and they're actually quite cheap, right? So you can come down here, I think it's like 4 cents an hour or something like that. Like, yeah, so I'm sorry, 18 cents an hour for this particular machine, which is actually pretty nice. So it's not terribly expensive, but if you're already in GitHub, you can probably just go to code and say, hey, create a code space if you're in the program, and then boom, you're off and running to the races, which is fantastic. So we will be using this in just a second. The way that I did that is, if you look at this particular repo here, I call it Clean Workspace. And what I do is I create different branches, and in each branch, I actually configure the container that I need for that type of thing I'm doing in that branch. For example, here, and I'll show you a cool trick. Here I am in GitHub, and all I'm going to do is I'm going to press the period key on my keyboard. And what it's going to do is it's actually going to load this repository in a really lightweight web editor that looks a lot like Visual Studio Code. You don't have access to the terminal, but you do have the same keyboard shortcuts and navigation that you want to. So I'm not having to click on a link, look at it raw, go back, click on a link. I can say, hey, I want to see all the files in this repository. I just click on that period, and then boom, now I can see exactly what I've done. I have this little script here where I'm actually installing K3D. Those who aren't familiar with K3D, it's basically a Kubernetes cluster run inside of a Docker image, which is so funny to me, because what you normally do is you build up all these VMs so that you can install Kubernetes so that you can run Docker inside of Kubernetes. But what we've done is we've taken Docker and we've shoved the Kubernetes inside there so I can then run Docker containers inside of my Kubernetes that is running inside of a Docker container, which is freaking hilarious. But it's awesome for development because it's really small, it's really easy to configure, and it's really easy to stand up, but it runs just like Kubernetes. So kubectl doesn't know if it's talking to a full K8s or if it's talking to a K3D, which is really cool. So all I did is I said, hey, I need you to spin up an environment for me. And in that environment, I want you to mount these particular ports for me. I want you to install different extensions for me. So there's a lot of extensions you'll see that I'll be using, that'll be lighting up and syntax highlighting and color coding and all this kind of stuff. I don't have to remember what extensions there are. My Visual Studio Code doesn't even have to have those extensions installed. When I connect to this code space, it will automatically install all these extensions for me, so I have that rich experience every single time I connect to it. So what I've done is I've used this particular thing to spin up that environment, which is where we're going to work. Now, if I come here to Clean Workspace and I come down to code, you can see I already have a couple code spaces already running, but the one I want is the one for Helm. But I have one for Web3, I have one that's for main, which is where I actually build Docker images, because it has Docker inside of Docker. So when I'm trying to build a Docker image to use with code spaces, I can actually use code spaces to build the image that I'm going to use later in a different code space, which is a lot of fun too. So what it's doing now is now I'm actually inside this environment. So I've spun up a code space, and this is the exact same one I just showed you here with the exact same 2 files with the K3D. But what happened is this is already running and has Kubernetes installed, and it has all the tools that I need installed as well. And this is where I'm going to do the demo from today. Now, as you notice, I am sitting inside of a web browser. And this is fine, and you can actually be very productive here. The only problem I have when I'm inside of a web browser is I like to press Control F4 a lot to close the tab that I'm currently working on. But if you do Control F4 in a web browser, it actually closes the tab that had my Visual Studio Code in it, and it causes me lots of nightmare. So what I do is I come down here and say, hey, I need you to open this exact same environment, but actually open it in Visual Studio Code on my machine. Now all my keyboard shortcuts are going to be interpreted by Visual Studio Code and not by my web browser. That might cause me some heartburn and heartache. So what it's doing down here at the bottom is you can see it's activating all these extensions. And then eventually you're going to see this over here switch and say, hey, I'm now connecting to that code space environment that you have in the cloud. And everything that you do inside of this Visual Studio Code is actually happening on that remote machine for you. So this extension is fantastic. And all it's doing right now is activating everything. And in just a moment, we're going to start connecting to that environment where I can then do the demo. So we are opening remote connection. What I'm going to do here is I also want to encourage people to come off of mute when you have a question, grab my attention. It makes it more fun for me too. And I want to make sure that we take the conversation where you want it to go. So I'm going to stop here for a second and see if anyone has any questions just over what we're going to cover or code spaces before we start jumping into learning Helm together. And I will take silence as agreement.
I actually have a question for you. You mentioned earlier you had a Kubernetes, I'm sorry, you had a Docker running inside of Kubernetes, which was running inside of a Docker container?
Yeah.
And what was that purpose of that, just so that you could do it, or was there another business purpose behind it?
Okay, great, good question. So standing up a Kubernetes cluster, especially locally, can sometimes be a pain in the butt. Like it just is. Docker for desktops made that a lot easier, right? Now you can just fire up Docker for desktop, enable Kubernetes support, and then you have a Kubernetes cluster. But if I'm not on Docker for desktop, or I'm on a Linux machine where Docker for desktop doesn't even exist yet, but I think they're working on it, I need another way to have a Kubernetes cluster without having the full-blown control plane, all the nodes I have to keep running, and all that scary stuff. So what you can do instead is you can actually run K3D, which is an implementation of Kubernetes, but you run it inside of a Docker container. So almost every Linux machine has Docker on it nowadays, and all I have to do is say, hey, run this K3 image inside of you, and then all of a sudden I have access to a full Kubernetes cluster. So for me, it's just about getting that inner loop for the developer really tight and convenient.
Gotcha. Okay, thanks.
Oh yeah, no problem. Another thing that I'm going to do, which a lot of people don't realize, is that I don't like Bash. I've seen the light, and I know that PowerShell is better. And we can have a religious war after I'm done with my demo on Bash versus PowerShell. But trust me, once you understand that PowerShell is dealing with objects and not text, you realize that the objects put the power in PowerShell. So this entire demo, although I'm on Linux, is going to be done inside of PowerShell. PowerShell works on Mac, Windows, and Linux machines, so that you can use this exact same thing everywhere. The only way you're using Bash on Windows is to first install WSL and all that stuff. But PowerShell just works everywhere. There's a lot of cool stuff you can do with PowerShell once you get over the fact that it's not Bash. And a lot of people are just mad at it because it's not Bash, but you need to kind of accept the fact that it's different for a reason, and the reason is because it's awesome. So I'll show you some fun stuff that I'll be doing with PowerShell here as well. So the first thing we want to talk about is Helm itself. So let me go ahead and maximize this window, and I'm just going to type the command Helm, and let's see what happens here. So we can see what kind of commands are available to us. And there's a lot that Helm can do, as you can just see from the available commands. One of the commands that I don't see people using often enough, in my opinion, is the very first one called completion. What completion will do is it will give you tab completion for several different types of consoles. So right now in this terminal, if I were to type Helm tab, nothing would happen. But I'd love it for it to offer me all the different commands inside of Helm so I don't fat finger something. So what I can do now is I can simply say I want to do a Helm, and I want to use the completion command, and I want to do this for PowerShell. Now, if I just press enter, what it's going to do is it's basically going to dump the script that it's about to execute for me to give me tab completion inside of PowerShell. I just do this so that you can see what this script looks like. But what I really want to do is come here. I want to pipe this to out string, basically saying make sure this is formatted as a string. I want to execute that text as a script inside of PowerShell. Now watch this. If I type Helm and I hit tab, all of a sudden I'm listed all the different commands that are inside of the Helm, and I can do things like create tab, and now I'm much more efficient because I get to tab complete. Let's create something called my chart. What we're doing now is we're creating an out-of-the-box hello world Helm chart, and we're just going to go poke around and look at it. And I'm going to walk you through the experience I had when I was first working with this particular project. All right, cool. I have a Helm chart here. And let's look around. Oh, it has a charts folder. It's called a Helm chart. I bet you there's some cool stuff in the charts folder, but the charts folder is empty. So I'm a little confused. I'm like, oh, that's weird that it's empty. But let me see templates. What's inside a template? Oh, Deployments, okay, great. I know what a YAML deployment is. I've done this with kubectl before, so I open it up, but this doesn't look like any deployment I've ever seen. And if you're familiar with deployments for Kubernetes, you know that this doesn't look right. Like, what are all these curly braces doing? Why are there pipe symbols in here? I don't understand what values is. This is very intimidating. And all of a sudden, I'm starting to get nervous because I thought I would recognize a deployment YAML, but I don't recognize this deployment YAML. So let me think, what else do I do? Okay, helpers. It has help in the name. If it has help in the name, this has to help me. But when I opened it, this didn't help me at all. This helped me get more confused than I already was because I have no idea how anything in this file is supposed to help me deploy stuff inside of my Kubernetes cluster. Then I thought, okay, I'm in bad shape when the thing with the word help in it doesn't help me. But what about a text file? We all know how to read a text file. Notepad can open a text file. So I open the text file, and yet again, I am stuck here thinking to myself, I have no idea how to read a simple text file. At this point, I panicked, and I was like, all right, again, Helm's not for me. This is not what I want. I just came over here, and I just deleted the entire thing. And I took a breath and said, okay, this is better. But how am I supposed to go learn this when you do a hello world, and it's completely crazy inside of hello world? And what I decided to do was create an empty folder and keep asking Helm, tell me when I have a chart. I want to know the bare minimum required to actually have a functioning chart that I can use with Helm. So what I did, and what we're going to do today, is I opened up a terminal window, and I want to shorten this up, so I'm going to set this as Helm. All I did is just reduce all this text on the left-hand side. That's a cool PowerShell trick. I could call out anything that I want, and now my terminal looks nice and clean. And what I want to do now is create a new folder, so I'm going to make and change directory to something called my chart. Again, that's a cool PowerShell thing. You see that? I made a directory and jumped inside of it with one command without having to semicolon cd and makdr and all that kind of stuff. So again, I'm a big fan of PowerShell if you haven't picked that up yet. So let me see, is this a chart? So what you can do is you can say Helm show, which is a command that has chart. And what you can do is it says, hey, Donovan, this folder, as it sits right now, is not a chart. The reason it's not a chart is because you're missing a file called chart.yaml. I'm like, all right, great. Let me go ahead and create chart.yaml and then ask it again. Now is this a chart? It says, you're closer. I'm not complaining about the fact that you don't have a chart.yaml, but that chart.yaml has to have a name inside. I'm like, okay, so let's add a name. We'll just call it my chart, and we'll add it to chart.yaml. Ask again, is this a chart? It says, nope, it's not a chart because it also has to have a version inside of it. No problem. Let's add a version. Version, we'll use semantic versioning. I'm a big fan of semantic versioning if you use it correctly. If you're not using it correctly, go watch my video on YouTube that explains exactly how semantic versioning works, and then you can start using it correctly. All right, I have a name, I have a file, I have a version. Is this a chart? Look at that. We have a chart. So all that other stuff we saw, the notes file, the helpers file, those weird deployments, the templates folder, the values file, like all that stuff, none of that stuff is required for us to have a legitimate working chart. One thing that I find interesting though, is that I only added a name and a version, but you see that there's this API version in there. So I was thinking to myself, how did that get in there? Because I didn't add that in there. And I wonder what else can be inside of a chart file. I wonder what else can make a template a template. And then I started thinking about what process or what tools might there be that could help me figure out what else belongs inside of this particular template. And I'm really old when it comes to writing software. I live here in Houston, Texas. I live right down the street from what used to be Compaq Computers, which is now HP. That is where I started my career back in the 90s. And back then, we didn't have things like syntax highlighting. We didn't have things like auto-completion. You had to go to the MFC book and actually look up the functions and stuff that you actually wanted to go write. And we definitely didn't have anything called linters. But linters are a thing now. And what linters can do is they can give you hints on things you might want to do. And lo and behold, Helm has a linter in it. So what I'm able to do is simply say Helm lint. And it says, all right, Donovan, these are the other things that you can do to polish this particular chart and make it better. What I find really interesting is that the number one thing there says it's an error for you not to put API version, which obviously can't be true because it just showed me that the API version automatically gets set. So I might have to put a pull request for that because if anything, that's a warning, but definitely not an error. So let's go ahead and fix that though. So what we're going to do is we're going to say, hey, I need to add an API version and it's a string. We're going to go ahead and go upgrade to V2. and we're going to put that inside of chart.yaml. And then it says you also need an icon. So I had to look up what an icon is. And what an icon is simply a URL to some icon somewhere that you want to be displayed with your chart. And so if it's inside of a registry, which we'll talk about later, you'll be able to see an icon that represents it. I don't have an icon, but I don't want it mad at me, so I'm just going to tell it I have an icon. We're going to say icon equals HTTP : whack whack some image that we'll fill in at some point in the future. Let's put that in chart.yaml as well. Then it says you should have something called a values.yaml file, which was in the default chart. It doesn't have to have anything in it, but it needs to exist. So let's go ahead and create a values.yaml file. And then finally, you should have a templates folder. Great. So let's make a directory called templates. All right, now let's ask the linter now how we're doing. Perfect. No warnings, no errors, chart links perfectly. And if I were to do a Helm show chart, voila, everything's done. This looks really good. So now I have a legitimate chart. And I want to prove that this is a legitimate chart by actually deploying this chart to a Kubernetes cluster. So if I were to come down here, we're just going to do a CLS, and do a Helm Install. And we have to name our release. We're just going to call it my chart. And we're in the folder. So what you normally provided is the folder that holds the chart. I'm just going to use dot because we happen to be in the folder that defines the chart. And I press enter. And what we're going to see is Helm's going to come back and say, hey, I deployed successfully. I'm revision number 1 of your particular item. If you upgrade this, the revision will change so that you'll know how many times you've actually upgraded this particular chart. And if I were to use the Helm list command, I can now see that I have successfully deployed a Helm chart inside of my Kubernetes cluster. The boring thing here is that I didn't actually deploy anything because my templates folder is empty, which is where I'll have my config maps and services and pods and deployments and all the other type of resource types that you can put inside of a Kubernetes cluster. They need to be inside of our templates folder. So at this point, I've proven that you can actually create a chart with bare minimum files. Helm will happily take a chart, even if it doesn't transform any templates. And the thing that I like most about Helm is that I can go Helm Uninstall and say my chart. And all the templates that I might have installed have also been uninstalled for me. If I do a Helm list, we're now going to see that there's absolutely nothing in our chart. I'm going to stop there before we actually start adding templates to make sure everyone understands the bare minimum. All we created was an empty values file, a charts file that has all the information that we just did together, and an empty templates folder. That is a chart. All that other stuff you saw in that hello world create new chart is just extra stuff that we'll get to throughout the rest of this talk. So are there any questions over what we've covered so far? All right, so let's go and create our first object that we want to deploy inside of our Kubernetes cluster. And we're going to do the simplest thing I can think of, which is a config map. What we're going to do is clear the screen. And let's touch inside of the templates folder, my config map.yaml. All right, and then we're going to go config. And then I want to go ahead and create a config map. So I'm going to name it my config map. And I'm going to put 3 messages in here. So all a config map is a key value pair. So I'm going to call MSG1. And of course, we're going to put hello world. That's everyone's first message. Then I'm going to have MSG2, or we're going to say from, and then MSG3, me, Donovan Brown. What I've said is, hey, Kubernetes, I want you to create something called a config map. I want you to store it inside of Kubernetes so that my other pods will have access to this name value pair. This could be a connection string, a URL, or some type of information that I don't want to hard code into a particular application, that I want them to be able to pull this, because I could always update this config map and my entire application changes behavior. So that's why I want to do this here. Now, what we're going to do is we're going to install this to start to see how Helm helps us install these kind of things here. So let me go back here. And instead of actually installing it, I'm going to teach you some other things you can do to test what would happen should you choose to install it. Because depending on your Kubernetes cluster, you might not just want to be deploying stuff in there willy-nilly. You might want to make sure it's going to work before you actually go and execute your install command. So what we're going to do is we're going to do a Helm install. It's called my chart. We're still in the same folder. And then we're going to do a dry run. So what dry run says, this is what I would do to your cluster if you actually wanted me to run, but I'm not going to do it. So it's a nice way to review. And then finally, we're going to say also debug. What debug will do is it'll just dump additional information to the console so that I can make sure that everything is being pulled from the right location, that it's all being consolidated correctly and written the way that I want it to be written. So I'm going to press enter here. And what it does is it says, here you go, Donovan. I would have deployed a config map with these values inside of your Kubernetes cluster if you didn't use the dry run and the debug flag, which I did. One thing I want you to keep an eye on is up here, the user supplied values and the computed values are empty. Those won't be empty for long, and that's when the light bulb started to come on for me for how powerful this tool is. Yeah, dumping all of my YAML files into the templates folder, being able to type Helm Install and Helm Uninstall, and it automatically install and uninstall all those templates, that already adds value. But when I realized that my dev environment, my QA environment, and my prod environments are just slightly different, and that if I could parameterize those templates, then all of a sudden I wouldn't have to have 3 different copies of this file. I just want to replace the URL. I just want to replace the connection string. I just want to pass in the password that I actually need. And then all of a sudden, this one chart can be used in dev, QA, and prod. And I'm going to show you how you can start to move the values around so that we can do just that and customize them. So what we're going to do is we're going to go back to our config map, and I'm going to take these 3 values here, and I'm going to move them into the values file it had us create. This is just YAML. I can't see you guys, but I'm sure if I were to ask you to raise your hand and tell me how many people hate YAML, more than one person would raise their hand. I used to hate YAML as well. I say used to because at one point, again, I got fed up with YAML, and I was like, why does this stupid thing even exist? JSON is awesome. JSON is forgiving. It doesn't use white space. It's another reason I had a hard time with Python. Anything that makes white space significant is horrible. But then I went and I did a video. You can go to my YouTube and find the 10 things you do not know about YAML. Doing the research, and it was hours and hours of research to build this like 4-minute video on YAML. Holy mackerel, YAML is an incredibly, it's a language. Like, it's not just text. It's pretty powerful. And it's also a superset of JSON, which means every JSON file is actually YAML. But I'll digress. Go watch that video if you're interested in why I no longer hate YAML, but I did just like everyone else. Why did I move all these values into the values file versus leaving them hard-coded like I had before? Because what we can do now is I can come over here, and I am going to show you that I can replace these. I'm going to grab these 3 values here, and instead of hard-coding them, I'm going to use those crazy curly braces that we were talking about. So all those curly braces we saw earlier that I was like, man, I have no idea why these curly braces are there. That is your way of saying, hey, Helm, in between these curly braces, I want you to do something for me. I want you to replace values. I want you to transform data. I want you to do if conditions, all kinds of cool Go scripting language type of things. That's what happens inside of these curly braces. When you're dealing with a Helm chart, there is a global object that's always around, and off of that object are different properties. One of them is values, one of them is release, one of them is chart, and we'll talk about a couple of those in just a minute. But if you press the dot key on your keyboard when you're in one of these curly braces, you're basically saying, I now want to use the dot operator to get to a property of the global object that is always available inside of Helm. What I'm going to do is say dot values. As you can see, it's auto-completing that for me. So that's saying, hey, there's a values file, and inside there is a YAML file, and I want you to take all the properties out of that YAML file and make them available to me off of this object called values. We now know that inside there is a message 1, message 2, and a message 3. All I've done now, we should get the exact same end result, but I've moved the file so that I'll show you why I moved them here in just a second and how we'll be able to override some of those values as well. So now that I have it fixed, if I did everything correctly, I should be able to come here and let's do another install. Let me go ahead and clear the screen as well. The output is exactly the same. Hello world from Donovan Brown. But if you look up here, computed values are now not 0. Before they were empty. Remember, we had empty user supplied values, we had empty computed values, and then we just had the config map pop out at the bottom. Now all of a sudden computed values are actually populated. What they did is they said I had to go compute what message 1 would be, because there's several different sources for message 1. The values.yaml file is one such source. and it went in there and said, I'm going to read everything out of values.yaml as the default values for all of the things that might want to be replaced. And then I'll show you ways that we can override those with different features of Helm so that we can start to tweak things for dev, QA, and prod, sensitive information, and things like that. But the output is exactly the same. We haven't broken anything. So what if in my dev environment, message 2 needs to be different than it is in my QA environment, my staging environment, and my production environment? I'm sure you can imagine a scenario where there is a value that needs to be different per environment. What I would want you to do is not have 3 different Helm charts with that one value changed. What I'd want you to be able to do is create a file for that specific environment and only place the value that is different for that environment. So let's pretend that we're going to do that. So what I'm going to do is I'm going to say I want message 2 to be dev when I'm in the dev environment. And what I'm going to do is I'm going to create a dev.yaml file. Right next to my values.yaml, I now have a dev.yaml that has overridden the value of message 2 from the word from to the word dev. Now, how do I tell Helm I need you to use both of these files when you're actually creating my deployment? What I can do is here on my install command, I can add an F flag that says there's a file, and I can pass as many of these files as I want. And I'm saying there's a file called dev.yaml that I want you to use to calculate or compute what the value should actually be. If I press enter here, what we'll see is the computed values are different, and even the user supplied values are different. The user provided or supplied a value message 2 that is equal to dev. I computed that it should be dev when I took the defaults from values.yaml. I added what I found in dev.yaml. I put those 2 together, and I realized that down here, it should be hello world dev Donovan Brown, which is kind of cool. So now you're starting to see the power of being able to override the values. I'm going to show you one other way to override values, and then I'm going to start the question. Let's start over again. What if I wanted message 3 to be something sensitive like a password? I'm a big DevOps guy. If you've ever seen me speak before, chances are I was talking about DevOps. So I'm always thinking about how do I put things in pipelines. A lot of times we need sensitive information to be passed into an application like a password, a service token, a personal access token, a service principal key. That's sensitive information. And that information you do not want to check into source control. I want to be able to replace that at runtime. And many systems like GitHub Actions or Azure DevOps or Jenkins or all those CI/CD systems usually have a way for you to store secrets securely. Or you might use something like HashiCorp Vault or Azure Key Vault to be able to store that sensitive information. And then what you want to do is throughout your pipeline, as your pipeline is running, you want to go retrieve that sensitive information and then write it at runtime into the instance of the application. You do not want to check it in the source control. And Helm allows you to do that as well. If I were to run this exact same Helm install command inside of my CI/CD pipeline, what I would be able to do is say, I want to set message 3, for example, something else. And I would pass in that sensitive information from whatever strong box that particular system provides me to be able to securely pass in that sensitive information that would then be written to my pods and deployed to my application. And I probably would not be setting this inside of a config map, to be perfectly clear. I would be setting this inside of a Kubernetes secret potentially, or not even using the secret at all and getting it directly from Key Vault. But I just wanted to show you that you can pass in values from the values.yaml file. You can pass in values from files that you provide on the command line, or you can directly set particular items. And I'll set this one to my wife's name, which is Chelsea. I press enter here. What we're going to see again, user supplied. I supplied from the dev.yaml file. I provided from the actual command line, and I computed that it should be hello world dev Chelsea. And down here at the bottom, I don't think that got deployed to my Kubernetes cluster was that config map that took data from all 3 places. This is when I got excited. I was like, oh man, this is awesome. I can now take the exact same Helm chart and deploy it through all my environments in a very secure way. And now what we're going to do is basically keep building on this ability to replace data and polish data and put it throughout your charts so that when we go back and look at a completed chart again, which we'll do here before we end, it'll all make a lot more sense. So I'm going to stop here. Are there any questions on how I got the data in there or when you might use one of these particular techniques to get data into your chart? Okay, so what we're going to do now is we're going to start to polish some of the data that we have inside of our Helm chart. What if I wanted hello world or message one to always be uppercase, no matter how it was provided, no matter how the person typed in the value. I need that to always be uppercase. I want to make sure that it's never longer than 5 characters, and let's make sure it's quoted like a string. How would I be able to do that? Well, you can use the Go scripting language inside those curly braces like I showed earlier to do that. So let's go ahead, open our config map again. And what I'm going to do is I'm simply going to pipe this and say, I would like to uppercase this thing. And as you can see, it's giving me tooltips for some of the different things I can do. I can uppercase this. I can truncate this thing to 5 characters, and I can quote it like a string. All I'm doing is saying, take the value on the left, give it to the function on the right, take the output of that and give it to the function to its right, and so on and so forth. So I take whatever's inside message one, I uppercase all the characters, I take the uppercase version of that word, I truncate it to 5 characters, I then take that 5 characters and I quote it. If you were to do these in the wrong order, you can get some really weird stuff. So if you were to quote it before you truncated it, you might be taking the quotes off the string. So just be careful of your order of operations, because if you put quotes anywhere besides last, sometimes you can get yourself in a lot of trouble. So now what will happen if I run this? So if I were to come down here, let's just run this again. And what we should see is that hello has been all uppercased. It's now quoted as a string, and it's only the first 5 characters, which is awesome. So now I'm starting to realize that, wow, I can actually polish and sanitize data that I'm getting from my user versus having this big, long, crazy README on this has to be a certain thing, this has to be a certain number of characters, yada, yada, yada. I can just say, give me what you want. I'll make sure that it fits the shape of the data that I need. Now, what you can do is you can use any of the actual functions that are available inside of the template language. And this is just the Go scripting language. So if you're familiar with the Go scripting language, you have some idea of the power that you have available to you. Regular expressions, reflections, networking, math, lists, dictionaries, all kinds of cool stuff can be there. And you can just pipe what's on the left to the function on the right, and then output the value that you actually want. Just wanted to show you that you have a lot of power at your disposal. But what if I want to go ahead and apply upper trunk 5 and quote all of these values here? I don't want to have to copy and paste this, because if I decide instead of it all being uppercase, I want it to all be lowercase, I have all those places I have to go and fix. It'd be nice if I could define almost a function or a template that says, I want you to treat all data that I pass to this template with these particular functions. And I can actually do that. So what we're going to do is we're going to highlight all of this, and we're going to create another file inside of the templates folder. So we're going to touch templates, and we're going to call this underscore helpers.tpl. It is extremely important that I start that file with an underscore, because everything inside of the templates folder, Helm tries to take, assumes that it's a YAML for Kubernetes, and tries to deploy it inside of Kubernetes, unless the file starts with an underscore. That tells Helm, hey, there's data in here I want you to understand and I want you to interpret, but do not try to deploy this file into my Kubernetes cluster. Just read everything inside of it, because you might need to use some of it inside of the rest of my templates. So make sure you start it with an underscore. The name of it really doesn't matter if it's helpers or helper. I've written it both ways. Now what I want to do is I want to define an actual template. And what you need is you need to give the template a name. What I had before is uppercase. To prove that I'm using the template, I'm going to change this one to lowercase everything. So we're going to call this lower trunk. What we're going to do is we're going to lowercase things and we're going to truncate. I'm going to give myself the curly braces again. And something that you're going to want to keep note of is I'm going to put a hyphens at the front and the back. Why did I put the hyphens on either end of this? Remember I said YAML uses white space is significant? If you do not put those hyphens there, any white space between those curly braces, we're going to use it when we replace this particular template, which could throw off the indenting and the spacing inside of your actual deployment YAML, at which point it will actually fail. So by putting that says, where I put the template, that is exactly where I want this executed. Do not think that any of the white space between these dashes is significant. It is not. Leave that off, and you can put a hyphen in the front or the back. If you only want to trim the space in the back, or you only want to trim the space in the front, it depends on where you want to put your hyphens. I put them on both ends because I don't need it to do white space on either side. And now what I do is I paste exactly what I had before. But if I were to run this template would only ever work against message one. I'm explicitly saying, from the global object, give me the values, and then from there, give me the message one. What I really want to do is I want to pass in the value that I want to be operated on at this function, And the way that you do that is you basically say, I'm going to provide you the object. So dot will be whatever it is that I pass into you. And from there, I want you to uppercase it, truncate it to 5 characters, and then quote that particular value for me. So this looks good. Now all I have to do is come over here, and I'm going to delete all of this. Okay, and then I am going to come over here, and on these 3 lines, I'm going to do template. And then make sure you use double quotes here. You use single quotes, this will not work. I know that the hard way, and it's difficult to troubleshoot. So I'm just giving you a tip. You want to make sure that you use double quotes inside of here. And I think we called it lower trunk. And one thing I forgot to do in lower trunk was actually switch this to lower. So make it just to lower. So now it's going to take whatever I get it, lowercase it, truncate it to 5 characters, and quote it. And I'm saying use that template on all 3 of these values, value 1, value 2, and value 3. And if I did this correctly, see what happens. Voila. Everything is now lowercase, everything is now truncated to 5 characters, and everything is now quoted as a string. Just imagine all the cool stuff I could do inside of these templates. If I need data to be a certain way, I need it to be indented a certain way, if I need it to be polished in any way, I can sanitize that data in a very common way and then use that data throughout my entire template. So now we've kind of got an idea of the things that we can do to get data into our template and things that we can do to the data once we have it inside of our template before it gets written out to our particular deployment, which is great. Now, there was another file that scared me to death, which shouldn't have, which was that notes file. And what I want to do is show you what the notes file actually does and how you can use it so that when we see one again, it won't be very scary. This also has to be in the templates folder, and the word notes has to be all uppercase and text has to be lowercase. Again, get the casing wrong, does not work, thanks to the power of Linux. Casing is significant. So let's touch inside the templates folder, capital notes dot lowercase text. And then what I'm going to do is I'm going to open this, and anything I type in here will be shown to the user. And I can use templates in here. So I can say template, we're going to do lower, oh, don't forget my quotes, lower trunk. And then here's that dot I was telling you about. And if I do control space, it shows you that there's a capabilities, a chart, a files, a release, and a values property hanging off of that. That AAA is just for me doing test-driven development. That's just a snippet that I wrote. What we want to do is we want to go to release. And if I press dot here and control space, you can see that it has is installed, is upgrade, name, namespace, and I'm just going to choose the name. Well, I want you to know that that global object that's available throughout the templates folder has more on it than just the values file. It has releases, charts, and you can ask for files and the name of your release and all kinds of cool stuff. So if I've done this correctly, lower trunk, template, release, great. So if I were to come down here then, and run this again, what should happen is at the bottom of this, it says anything I type in here will be shown to the user, and then it basically lowercased, truncated to 5 characters, and quoted the name of the chart release, which was my chart. So it basically dropped off the RT on my chart. So that notes file can be used to share whatever information that the user of your chart might need to know after successfully deploying your chart. I have one of these inside of a repo where I do some Dapper demos. And you can use Helm to deploy the charts and everything into a Kubernetes cluster. And what I say at the bottom is exactly how to restart the entire application, because you can shut the application down. It's doing Twitter sentiment analysis using AI in Azure. But what I was able to also do is determine if the person who ran my chart was using Bash or was using PowerShell, because the continuation character at the end is different. So I didn't want you to copy and paste the text that I showed you if you were using Bash and then you paste it inside of PowerShell or vice versa. So it's really powerful what you can do, because you can use if statements and all sorts of stuff to say, am I displaying the correct data to the user based on their usage of my particular chart? So what we're going to do is we're going to stop playing with this chart and go play with other charts. So before I make that transition of going into a brand new chart, and we'll talk about testing and some other things, are there any questions over what I've shown? Because if you don't understand this, we're about to go really fast into stuff that I assume you grokked everything that I just said. So I'm going to wait a little longer for people to come off of mute or raise their hand if you have a question over anything that we've just covered. All right, buckle up because we're about to start going really, really quick, because the stuff we're going to be talking about is testing. Then we're going to talk about dependencies. And after we talk about testing and dependencies, we'll be done. And then you can ask me whatever else you might want to ask me about this or about anything else you might want to talk about. So let's back up a level. And let's create 2 more charts. We're going to do Helm create. We'll just call it 1. And then we'll call Helm create. And we'll call the other one 2. And what we're going to do is we're going to have 1 depend on 2. But before we do that, we're going to go look at testing. Let's do a couple things first. First, let's open up 1. And as you'll notice, the charts is empty still. But when we talk about dependencies, that will change. Let's come over here to our templates folder. In the test, we're about to go play with those. But before, I want to show you these files again that were so intimidating before, and see that they're not so intimidating anymore, because you now understand what it is that we're doing. We're defining this particular template called one name, and we're basically taking in this information and we're truncating it to 63 characters. We're trimming any suffix off of it that ends with the with a hash, excuse me. Here you can see that we have if statements in here as well, so that we can do if statements. There's with statements, so I can do looping. This is an entire programming language that allows us to take in data, polish it and manipulate it, and then spit it back out in the exact way that we need it for our chart throughout our project. So it actually does help you. Once you understand how to read it, the helpers actually do help you. The other thing is, here's a deployment, and now we understand. Okay, so we're basically using that one full name that we just saw over there. We're actually indenting this to 6 spaces to make sure that it doesn't break where it's supposed to show up in my chart. I'm using the pipe function to take it and just move it across our pipeline here. I'm starting to understand what's going on here. With is basically pull secrets. So if I had multiple pull secrets, this would run multiple times because this is essentially a loop. Got it, right? So this isn't as scary anymore because I can see past the curly braces and into what this actual deployment is trying to do. And then finally, the notes file. As before, you understand now that these curly braces are just the templating engine being asked to do an if statement. If the ingress is enabled, I need to tell you about the ingress. But if ingress was not enabled, I don't need to tell you about ingress. So I can be very smart in what information I show to the user and don't show to the user, depending on what parameters they used when they actually deployed my particular chart. And then here, we're going to see that here's the chart file. And the chart file has a lot more in it than we put in it, right? It also has a description, which we didn't add, but you could obviously add a type. Not only does it have a version here, but it also has an app version, which is different from the API version. There's a lot of information that you can put inside of your chart.yaml to make it more discoverable, especially when it's being hosted inside of a registry somewhere. And then finally, let's look at the values file. This values file is not just a simple name value pair like I showed you before, but these are nested objects. So I can say image.repository equals nginx. I can have arrays, strings, objects to where I can have this annotations will have other name value pairs inside of it. So this is just full-blown YAML that allows you to go back in and define all the different variables that you're going to want to be able to manipulate before you deploy that particular chart. So I just want to let you know that it doesn't have to be as simple as I showed you. This values.yaml can be very, I don't want to use the word complex, but it's this very powerful way to be able to show what it is that you're actually trying to deploy. Now let's talk about testing. I am an enormous fan of testing. That's why you keep seeing that AAA tooltip or snippet, is because I write a lot of tests and I have the arrange, act, and assert method is the way that I write my test. So I was really excited when I saw, hey, Helm has testing in it. This is awesome. My favorite type of testing is unit testing. They're fast, they're efficient, and I can do it really easily on my dev machine. I obviously understand the importance of things like integration testing, load testing, exploratory testing, perf, get it. But unit testing is my bread and butter. So I was really excited to think, man, this is a cool way to be able to run a unit test. So let me go and try to see what this thing is about, because there is actually a test command on Helm. So I did Helm Test, press enter. It says you need a release. Oh man, if I have to actually deploy my chart before I can run my test, this really isn't a unit test. This is an integration test, because I have to deploy the actual app in a running environment before I can execute the test. I was a little disappointed, but hey, an integration test is better than no test. So let's go ahead and deploy this and see what happens if we try to run this particular test. I'm gonna go ahead and maximize this, clear my screen, and we need to do a Helm install. We're just going to call it one of the one folder. And when we install it, you can see here's without the notes file, right? This is everything that was in that notes file that we were just talking about. This is revision 1. It was deployed successfully. And now I can do Helm and I can do list. There we go. 1 is deployed. So let me go ahead and try to test this thing. So I'm going to do Helm Test 1. And what it does is it takes that YAML file that was the test, does whatever it says to do inside of that YAML file, and then outputs if it was successful or not. And this one actually succeeded. What we're doing with the out-of-the-box chart is we're deploying an Nginx. And Nginx, all we're saying is that if I try to go to the IP address on the correct port, I should get a 200 back. If I don't get a 200, then this didn't deploy successfully. If I do get a 200, everything's great. So all this is verifying is that that deployment deployed Nginx correctly, because when I tried to go to the port in the IP address, I got back a 200, which is fantastic. So I can prove that by simply doing a kubectl get pod. And there's my pod, but I really don't like the fact that there's still a test pod there. Imagine if I had 100 tests. Then I'm going to have 101 pods in here testing that one pod before. Like, this shouldn't stick around. So I thought, okay, no problem. I'm sure when I do a Helm Uninstall, it's going to uninstall everything. Not only the pod that was deployed as part of my deployment, but also that test pod. So if I go back and do a oh, look at that. That I don't like at all. So why is this thing staying around, especially if the test passed? I could understand if the test failed, I'd probably want the pod to stay around. Maybe I could go look at the logs, figure out why the test failed, and then go back in and fix it. But this I don't like at all. So I did some more research. And what I was able to find out is that there's a way that you can tell it. If I succeed, go ahead and wipe me away. But I'm going to go ahead and save you some time, because if you just add that one hook, which I'll show you how to do here in a second, and you try to run it again, it will fail. And it will fail because it says, hey, there's already a one test connection pod out there, so I failed. I'm like, yeah, but I need you to delete that one so that you can go run the test again to tell me if everything is okay. And there's actually a hook for that as well. So what we're going to do is we're going to apply both hooks at one point. We're going to cause this to clean itself up. We're going to fail the test, fix the test, and show you that entire workflow. So let's go back into the test itself. And this is the one part where if I am going to mess up this demo, this is where it's going to be, because it's a lot of typing. So here we're going to say helm.sh hook delete policy. Delete policy. Okay. And before hook creation, I want you to delete yourself. Creation. Also, hook succeeded, I want you to delete yourself. So that's saying if the test passed, delete yourself. If the test failed or succeeded and I didn't have this hook in there and there's already a pod there, delete that pod and then run the test again. That's essentially what I'm trying to do with this line of code. Hook delete policy, before hook creation, hook succeeded. All right, if I spelled everything correctly, and I am a notoriously horrible speller, then I should be better off. So now what I should be able to do is I can't just do a Helm test, because if I do a Helm list, there is nothing there. So let's go ahead and redeploy this. Helm install 1. Perfect. And now I'm going to go and run my test. And it should succeed. Perfect. And now if I do a k get pods, there is only one pod. So that ran the test passed, and it deleted the pod. Everything's great, and I'm happy. This is exactly what I wanted. But what happens when the test fails? So let's go and cause this test to fail. So it's basically saying, hey, I want you to use wget to go and basically download the name at this particular port. So let's just change this from port to ports with an S. So this shouldn't work. But watch this. When I go and I do Helm Test again, it actually works. But why does it work? It should fail. The reason why is because this is not a unit test, right? You have to deploy that change that I just made to the test into the Kubernetes cluster, because that's where the test actually runs. The test does not run off of the file on your hard drive. The test runs out of the actual hook inside of your Kubernetes cluster. And the hook still in my cluster is the original one that wasn't broken. So what I have to do is I have to deploy this one. Till this point, what I've been doing is I would do a Helm install, then a Helm uninstall, and then I'd install it again. You don't have to do that. You can actually do a Helm upgrade. So it's basically says, I want you to upgrade the chart that's already there because in Kubernetes will make sure that all that stuff happens in such a way, reduce downtime and things like that. So instead of doing a Helm Uninstall, I'm just going to do a Helm Upgrade of 1 from the 1 folder. And what you're going to notice is now it's going to take that new test, that broken test, and shove it inside of my Kubernetes cluster. And you'll notice here that my revision is now 2, letting me know that this is the second time that you've upgraded or modified this particular chart. So now if I were to come here and do a test, this test should fail. There it is, right there. Test failed. And if I were to do a cube, I don't want to keep typing that. So set alias of K to cube CTL, type K, much better. K get pod. You see it says status error because that test did not pass. Now, if I wanted to, I should be able to do, what is it? K logs, I think it is. Let's copy this. And as you can see, it says wget bad port spec. So the port that I was trying to use is no good. All right, so let's go fix that. So now I can come here, fix that the way it's supposed to be fixed. I can come here, another upgrade. This should be revision 3. Perfect. And as we saw, I still have 2 pods running because I have the failure pod. But now if I were to do a test, the test should pass now. And the test knows to clean up the failed pod, run the test again. And if the test succeeds, clean up that pod as well. We have a success here, which is fantastic. And if I were to do a K get pods, all of a sudden I only have 1 pod running. So this is the workflow that I want. It's okay if pods stay around if they failed, as long as I'm able to go correct those tests, however I'm going to do that, upgrade my template, and then run them again, and then all the pods magically clean themselves up. So this is the workflow I would encourage you to do. Why they don't actually stub out this test with this hook in it already, I don't know. Again, maybe I need to stop complaining and start sending some pull requests, because I think this is a no-brainer in that freaking in that template. This template should come with this already in there, so that I didn't have to go figure all that stuff out. So that's testing. The last thing we're going to talk about is dependencies, but as I've done several times already, and I'll do one more time, I'm going to go ahead and stop and let anyone ask me any questions that they have over anything that we've gone up through this far. And if not, then I'm going to keep going and do dependencies.
I think we're good. I don't see any questions in chat.
All right, great. Let's go to that final thing. I want Helm chart number 1 to depend on Helm chart number 2. And this is where their tagline finally becomes true, the package manager for Kubernetes. Because what I might depend on might actually live in a registry somewhere that is not on my local machine. So I'm going to be pulling it from Bitnami or whoever is this person providing me a WordPress or an Nginx or a MongoDB. There might be these charts out there that have these components that I need that I'm going to depend upon. To make my life easier, I'm just going to depend on another one on this particular machine. But I could depend on something that is remote to my machine as well. The way that I do that is I simply open up my chart file, and I'm going to scroll all the way to the bottom, and I'm going to say dependencies and name it. Again, do not forget that you're on Linux, because I typed a capital 2 once and was lost for way too long. Everything has to match to the letter, casing included, right? This is a pain that a person like myself who's been on Wintel boxes their entire life, this hurts me all the time. So make sure, if you're like me, pay attention to the casing, because it will become very, very painful. I know that the version out of the box is 0.1.0. And the last thing I need to tell it is, where do you go get this? It might get it from a URL, or in my case, on my file system. So I simply say this is file, whack, whack, back up 1 level in a folder called 2. Now what I've done is I've said that my chart 1, now depends on chart 2. And I can prove that by coming down here. And I'm going to ask Helm to do some dependency work for me. And I just want you to list all the dependencies of chart number 1. And it says, you depend on chart number 2 of this particular version that's located at this place, and it's missing. It's missing because in my 1.charts folder, it's empty. So what I can do is 2 ways. When I do the Helm Install command, I can actually say, I need you to go fetch all my dependencies for me as you're installing. Or if you want to go ahead and get those early, just go ahead and pull those down, you can actually have Helm do that for me. So I'm going to do Helm dependency update of 1. And now all of a sudden, you see right over here on the left-hand side, 2 showed up. What it did is it went and found my dependency, packaged it up for me, and shoved it in the charts folder. So now when I deploy chart number 1, I'm actually going to deploy chart number 1 and chart number 2. And I can demonstrate that for you here real quick. Let's do another Helm install of 1. And what I'm going to do is I'm going to go ahead and do from the 1 folder. And I want to do a dry run, so I don't want to actually do this. And let's just do debug for good measure. And let this run. And now if we scroll back up and you look very closely, you're going to notice that some of these things are coming from the 2 folder. That came from the 2 folder. That came from the 2 folder. And we're basically deploying those test everything from the 2 folder just as well as we were from the 1 folder. The thing I'm dependent on gets deployed first, then I get deployed after. Pretty simple. Now, I work with Jessica Dean, who some of you may know. She's also really big in the DevOps space, but she's also really big on the AKS side, right? Much more so than I am. And she comes from a Linux background. So whenever I'm confused on AKS or Linux, I reach out to Jessica. I had her look at one of my projects where I had one big Uber Helm chart for 3 different services. She says, nope, I don't like this at all. What you should do is break this down into 3 separate charts, 1 for each microservice, so that you can then deploy those microservices independent. I'm like, that's fine. I understand why you're saying that, but what do I do when there's a disaster? And I need to deploy all 3 of those charts right now, because I literally am moving from this region that just burned to the ground to this region where none of this stuff exists. And I don't want to have to run 3 different pipelines. I want to run 1 pipeline and have all 3 of my microservices deployed and running successfully. And the way that you can actually do that is you can use the dependencies with conditions. So what I could have done is actually created an Uber chart and then chose which of those individual microservices I actually want to deploy, and I can also deploy them all at the exact same time, giving us the best of both worlds if we want to. Let me show you exactly how to do that, and that'll be the last thing I show you before I'm done. So what I'm going to do is I'm going to go back to my chart file, and I'm going to add something called a condition. And a condition is just like what we were doing from the values.yaml file and all those other places. I can say to as the dependency and then enabled. So if this is true, which it is by default, and I run this, it'll automatically deploy both charts. But if I were to come down here, and then like before, say I want to set to.yaml equal to false, all of a sudden, this chart did not deploy anything out of the second chart. It only deployed the very first chart, which is kind of cool. But if I wanted to, I could then come in here and just set that either true or leave it blank because it's true by default, and then everything is actually set up. See, true enable equals false. If I wanted to have this in a global place, I could come down here in my values file. I could come here and I could simply say to, and I would change this to a colon, tab this over, change this to a colon, and either set this to false or to true, whatever I wanted that default value to be. And then I could override it with a dev file. Maybe I had a file called disaster, or I could just pass it in from the command line like I just saw it. But now I have this fine-grained control in the way that I can compose my Helm charts in a way that's best for me. Do I want 10 individual ones so that I can deploy them individually? But do I want this Uber one that then depends on those other 10 so that I can run that one when I have a disaster? Or do I always want to have one and I never actually run those individual charts individually? I just basically set values to true or false based on this one chart that I always deploy depending on what I am deploying. So that is everything that I know about Helm charts. And what's been exciting about this is now I use Helm charts a lot, and I'm able to use them with a lot of confidence and make sure that when I'm deploying to Kubernetes, I'm doing it in a repeatable way that I can then share this chart with people who might need to deploy the exact same application in their Kubernetes cluster. So that's what I came to show you. Hopefully you're not dizzy and you're like, okay, I think I understand what Helm does now and how to use it going forward in the future.
It was definitely a lot of really good information, but it's going to take some time to digest, and I think that's where the recording is going to come in handy. But yeah, a lot of great stuff. Wanted to pause for a minute and see if there's any questions. I don't see anything in chat. Does anyone have any questions verbally? Feel free to come off of mute.
I have a question. This is Brett.
Go ahead, Brad.
So I see a lot of times in deployments using the Helm charts where Helm times out. Is there an easy way to figure out why that happens, or is it to debug that kind of situation?
Even you can use the debug flag even when you're not using the dry run flag.
Okay, cool.
So I would do a Helm install whack debug and start to see exactly what it's trying to do and where it might be getting hung up for sure.
Awesome. Thank you.
Yep. I always use them together, but they are actually mutually exclusive. You can do a dry run without debug or a debug without dry run to get that extra information.
Cool. Awesome.
Cool. What else you have? Anyone else? I also have this. But yeah, you recorded this one too. So it's on YouTube a couple times, but I try to add something each time. So I don't think I did the dependency conditions the last time I did this. So every time I do it, I don't want someone to like, oh, I already saw that. If you watch long enough, you're going to see something in here that you didn't see the last time. So you've gotten a couple nuggets in here that weren't in the last time I did this for a user group. So if anyone watches this, they should probably watch yours. They should watch whatever the last one is because I'm going to try something else to add to it. But so far, you're the last one. I've done this a few times. I'm not sure how many more times I'll do it. So this might be the gold standard recording of this video going forward.
I like the sound of that, the gold standard, absolutely.
Yeah, exactly.
Any other questions or comments?
Definitely worth it. I learned a lot tonight.
Oh, thanks. I'm glad. And that's what's interesting is that process of learning that I just got frustrated, right? It's like, I just got to understand this. But what I've noticed is that you can apply that to a lot of things. Like it doesn't have to just be a Helm chart. Like literally start with the bare minimum. Don't start with this file new project that's a full MFC application. Like you really want to start off with main. How do I get main to run and actually fire up a window in Windows, right? Because when I used to start programming, I started with MFC and it scaffolded out this entire application and you're just confused right from the get-go. Behind me is like, there's a Win32 API Bible behind me. Like that, when I got that book and literally started with, here is the main file. And if you run this, a window will show up. I'm like, holy crap, like that's that easy to get a window on the screen. I thought I needed all this other stuff. And that's when I really started to learn. And when I learned like Win32, going back to MFC was like, oh, now at least I understand what you're doing for me. And I start to appreciate it. And I could troubleshoot things a lot quicker because I actually understood like why this was working. I didn't just understand MFC. I understood Win32, which was the library MFC was built on top of. So I've started to just go back to my roots and say, Donovan, stop getting things to work and start learning the thing that you're using. I mean, truly try to learn it to the point where you could then go teach it to someone else. And that's when I feel like I finally grasped something, is when I'm like, all right, I think I could go teach someone, like literally from an empty folder, how to build up a Helm chart. That's when I knew at that point, I knew how to do this thing and I could do it confidently for any project.
Man, MFC brings back memories.
Dude, it doesn't. I used to love it. Oh, sometimes I have like nostalgia because I used to listen to a lot of 311 when I coded when I was younger. If the right 311 song comes on, I am like right back into my parents' house upstairs on my compact computer, like writing MFC. I'm like, man, that was such a fun time. Even though I look at the programmers now, I'm like, how spoiled are these freaking programmers who have AI telling them, oh, by the way, this is how you write that entire function that you need, not just the one command, but the entire function's written for you. We went on GitHub for you and found this. Like, come on, man. It's getting a little bit too easy, but yeah, MFC. C and C++ were my first languages, and I was doing MFC and driver writing at Compaq when I started my career.
I actually started with OSF Motif way back when.
Wow.
And yeah, so that was a precursor to MFC.
Wow.
But yeah, goes
Very
way back.
Yeah, we're both old. That's basically what that means.
Thanks for highlighting that. Appreciate it. But seriously, on a serious note, thanks a lot, Donovan. It was very insightful. I think we all learned a lot, and I think it's going to do a lot of good to go back and rehash the video again. So
Awesome.
a lot of good information. Appreciate it.
Oh, it's my pleasure. Thanks for having me.
If there's no other questions for Donovan, I'd like to just go through a couple of closing slides. And let's go here. All right, so first off, as we mentioned, the recording for this presentation will be uploaded to YouTube in a couple days after some minor editing. If you subscribe to the channel, you'll get the upload notifications. And I posted the link for the YouTube channel over in the chat window, so you can subscribe there. Also, the events that we'll cover in just a little bit are going to be posted on my blog as well, samnasser.blogspot.com. And you can also subscribe to get updates regularly. And last but not least, there is a feedback eval link in the chat window. If you would please take a minute to fill that out so we can provide Donovan some feedback.
That would be great.
Before we close, I'm sorry?
So that would be great.
Excellent. Also, I wanted to mention a couple events that are going to be coming up April 19th through the 20th, Azure Cosmos DB Conference, and that is a free 2-day conference where you can attend and learn all about Cosmos. And the link for that is gotcosmos.com/conf. Pardon me, slide slipped through me there. On May 5th through the 7th is the Global Azure 2022 event, and that is a 3-day event that's going to be on all things Azure. And the link for that is globalazure.net. That is also a free event, and you can register for that. On May 6th in Columbus, Ohio is stirtrek.com. It's going to be running hybrid, some online presentations as well as in person. And if you're not familiar with StirTrek, highly invite you to come down and check it out in Columbus. Basically, it is a 1-day conference, and at the end, they close all the theaters. It's held in a theater, by the way. And at the end of the day, they close the theater, and we have a preview of a movie at the end of the day. And then lastly, on May 11th, which is the second Wednesday of May, is going to be the next meeting of Azure Cleveland. And there we're going to be talking about the Power BI ecosystem. So feel free to register for that on the meetup site. As we always like to do is discuss job openings. So you can always find job openings over on techsystems.com/IT-jobs. But in a more casual way, I always like to ask, who's hiring right now? Anyone know of any job openings that need to be filled?
Actually, we're hiring on the incubations team.
Excellent. And where can we find information on that?
Actually, if you go on Twitter right now, people are tweeting about it. On my so just go to my Twitter feed. So people are it happened. It didn't happen today, but people someone got excited and they found it like, hey, you can work with Donovan, and they started tweeting about it. So if you go to my feed right now, there are job openings, and you can see all of them, because that's just one of about 8 or 9 that we're hiring for PMs, engineers, and on the incubations team, like you said, we're working on stuff that we can't even talk to you about.
Oh, very cool.
Yeah.
Good to know. Thanks for sharing that.
Sure.
Anyone else who might be hiring? And on the opposite side of that token, anyone who's looking for work. And if you're reserved about saying it, feel free to send me an email or send me a private message, and I can link you with any of the job openings that we discussed here, or any of the recruiters that email me outside of that. And so with that, my contact information, snasser@nistechnologies.com. You can also find me on Twitter @SamNasser. And my blogspot, as I mentioned before, samnasser.blogspot.com. And lastly, I invite you to connect with me on LinkedIn. And so with that, once again, we'd like to say a big thank you to Donovan, and thank you all for attending, and look forward to seeing you next month.